Assalamu Alaikum. Welcome to another tutorial in IoT application. Uh, in this project, I have created one project using ESP8266 board. Let me explain about this. Uh, this is ESP8266 as I have already discussed, and we have four switches here. The one is the R meter input. You can see the tag with the input buttons and the R meter reset button along with, and here we have the counter input and the counter reset button. So when the counter button is pressed one time, there should be increment of 1, and the same will be sent to the cloud ThinkSpeak website. We will show on the cloud platform. And the R meter is actually incremented one by one when it is pressed and hold. If this button pressed and hold, then the system will count the second, okay, and the second after 60 second it will increment 1 in the memory EPROM of the this ESP8266, which will indicate that 1 mint has been count, and the same data will be sent to the ThinkSpeak's cloud platform. Okay, so I will also show you the wiring diagram here, because the wiring diagram you cannot understand properly. I will show you the diagram so that you can easily understand. Now let's move to the laptop, which has actually the built-in Wi-Fi. So this is actually the block diagram. Let me explain the project scope. What is the project? The project is actually to measure the equipment running hours and counter. There is two different input. This is R meter. This is R meter input. They are used at digital input D3, and this is the counter input at digital input 2. So when the counter button is pressed, it will count 1, and the R meter is dead until unless the button is pressed and hold. It will count 1 second every time, and when the second is equal to 60 means that 1, then it will count 1 minutes, and the data will be saved into the EEPROM of the ESP8266 for permanent backup. What is the issue actually that when the power restore, what we want that the data should be keep in the retentive memory of the ESP8266. That's why we not only read the data but also save in the permanent memory, and the most important thing after that, the same data will be sent to the cloud platform. Here I use the ThinkSpeak cloud platform. The same data will be sent to the ThinkSpeak. I will show you how the data is being sent there. Okay, so this is a complete block diagram, and this two button is for the reset. If you want to reset this R meter, you have to press this button. If you want to reset the counter, then you have to press this button, which is used at digital input 5, and this is digital input 4. Okay, this is block diagram. Now come to the coding. Here is the coding. I'm not going to explain each line deeply, but just I gave you very brief introduction about that. The main important thing is that what library you have to used here. You have to include EEPROM.h. This library is actually to read and write data in the EPROM of the your board ESP8266. And this is the ESP8266 Wi-Fi library, because this board has a built-in Wi-Fi. Then that you have to use this one. This is Wi-Fi client, and this is a ThinkSpeak library. This library is important and necessary if you want to send your data to the ThinkSpeak, because I will send my data to ThinkSpeak. That's why I include this library. Now here is some basic coding: constant, long, interval, 15. This is actually delay to send the data to the ThinkSpeak. Okay, and now come to the this part. This part is actually checking your the Wi-Fi SSID and password. This is I just connected it to my mobile hotspot. So this is the SSID name, and this is the password you have to write here. Okay. Now this coding is actually to ThinkSpeak setting. This is the using long defined my channel number. In order to send the data ThingSpeak, you need two different parameter. One is your channel number and one is API key. Before sending data, you must have to create your channel in ThingSpeak, because I have created. I also use for different purpose there to send data from the LabVIEW. So I already created. I have created on the video how to create the channel on the ThingSpeak. I will put the link in the description so that you can see that. So these two parameter you need: channel ID from your ThingSpeak platform, and this is the API key. Now these are the pin configuration for the R meter. This is for the counter, and this is just for simple checking the Wi-Fi connection. After that, it takes the input, initialize the pin. I use as a input as a pull up. You can use either pull up and pull down. Here the pin mode I configured as a pull up. Then R meter, it reads the data from the input and then write on the memory address on different time interval. Okay, you see, this is the previous value checking, then the minutes count. Okay, this is a little long code. I'm not going to explain everything, but I told you what it is doing. It is doing actually from two input. It is actually counting the pulses and counting the running hour. Okay, for counting pulse, I have given the name for the like a counter, and for running hour, the name is the R meter. Okay, here you can see the increment is going one by one, and if second is equal to 10, because this is for testing purpose, I just compared the second is equal to greater than 10, because if the second is equal to 10, it should be count 1, which I will replace this 10 to 60. That will represent each count as a 1 mint in order to count the R meter reading of the your equipment or plant whatsoever. Okay, so these are the complete coding. I have uploaded this one. Now let me show you the. I'm not going to tell you how to upload it, how to configure the board, and how to select the port number. These are the basic things. You see, my Arduino is connected on port number 3 from port 3, and you have to select your board, everything. I'm not going to discuss these all the things. Let me open the serial monitor. Okay, let's say I press button. Oh, it's not reading. Why? Meter input. Oh, it's reading. Now you see, I pressed and hold the R meter, so it is reading the second. Okay, now I leave. Now I want to press the counter input. Counter increment. Okay, the previous value was 17. Then again I press 18. Then again I press 19. Okay, I should also make the video so that you can easily understand the values here. Let me take the picture from here. Okay, I think no need. Let me show you the cloud platform. Okay, so this is my cloud, ThingSpeak cloud, where I configured. This is my channel ID. You see 824573. You can see also here channel ID 824573. Same channel ID, and this is the API key. API key I take from here. In ThinkSpeak, you always find it two different type of API key, write and read. So what I am doing, I am writing on the ThinkSpeak, then I have to use this key, write API key, 69U2 like this. Okay, this one is my this one I692. This one is API key. Okay, now data is being sent on the cloud. You can see here my private view. This is my channel. You see, this is the current date. What is the date? 7th of March 8:38. Okay, this data was sent. This is the R meter reading 11. 11 is it's actually showing 11 minutes, not R. It's 11 minutes. You can see also here on the, because when I last leave it, it was 9, so now it has become 11, and the counter reading is 19. You see, counter reading is 19. At 8:46 the data was sent. Now let me press again counter reading so you can see on real time values also. Okay, this is the counter reading. I press again 1. Now it has become 20, 21 like this, and this is the R meter input. Let's keep counting. Yes, counting, correct. Okay, now what is the next? What is the important things in the coding? Let me see that if anything important I want to tell you. Yeah, I remember one was very critical things which I faced the issue, then I make it resolve. I think it was from sending to ThingSpeak. Yeah. Okay, these are the addresses of the EPROM where data is being written permanent. Okay, even though the power is off, after when the on the power is stored, you can get the same data as it was the last. This is EPROM address 8, and it is taken as a long R meter data is written on 8, and in the same way, what is the address of writing the counter? Let me check from the coding. Where is that? This is SSID, integer, EPROM, R meter. Okay, EPROM, we write the data after counting the values. Okay, here actually the logic is made such that write long to EPROM values dot address. We have saved the values of address on the variable address. Okay. So in this way, you must have to put some delay sending data to ThingSpeak, because if you don't put any delay, then there will be issues in reading data in the cloud. Might be some data you read early and some data you read after some time. You see the current value is 11, okay, sorry 12 at 8:48, and this is 21. You can also see here on serial monitor, this is 21, this is a count value, this is the 21, and this is 12, and this is 7. Actually you see the 12, why it is a 12, it is minutes. Okay, minutes is 12. When then again after min, the value second becomes 0 and start from 0 to 10. If it goes to 10, then here will be 13. Okay, I show you. I press again the R meter values. Okay, okay, you see 8, 9, 10. 10 is equal to 13, means it has count 1 mint more, then the mint value is 13 and the second start again reading the values of 0 0 0 0 0. Okay, now you see the updated values will be here. Wait some minutes, here you see updated value has come 13. Okay, we have put the delays to writing some not very frequent after 1 mint or below 1 mint you can send data, but not very frequent because this is the free version of ThingSpeak, so it has limitation to send data on the cloud. If you send okay, one more important thing about that, the coding, is that we configured our coding in such a way, let's say there is a discontinuity in your Wi-Fi. Okay, then the system will keep running, system will keep performing its job as it was coded, means that the count meter and R meter will keep running your data, saving your data in EPROM. And whenever the system ESP8266 connect with the cloud, connect with the Wi-Fi, then the updated data from the EPROM it will send to the cloud, so that you can get the updated data on your cloud. Now this cloud is actually I created on the ThingSpeak, and this is my private. Okay, but you can see also in the public view because I shared it. Okay, you can remember this channel ID 824573. You can search on the public from the ThingSpeak public channels, and you can see many others ThingSpeak channel which are public, and people have make it the open so that anyone can see from anywhere the data of their cloud. So I hope you like this video about the ESP8266. This is actually one of the project which I have done with my colleague. So there are many projects we will create using this board and some Arduino board also. If you have any comments, need your any suggestion, you can contact me on from my channel contact number. Okay, the configuration of this channel you can also do something like that. I tell you, let's say you want the background, so you change, let's say I make it 30. You see the background value has changed. If you not observe, let's say I make it F0. See, from here you can change the background. You have to write is a hex code of the color, and the line color you can also change from here. You can need hex code, and the type of line you can type either you want line or you want bar like this. Okay, and you not, let's say you want column like this, let's say you want spline like this, or you want like step. Okay, whatsoever you want, but normally we like line. How many result you want, this is also important. How many samples you want here, let's say I want not 60, I want just 20, so only 20 sample will be shown here. Okay, you want also with respect to days, that how many days data you want to see on a single graph, you can do that. You can do different scaling, time scale, average, median, sum. Let's say I take the sum of 20, this last 20 values, this is the sum 127. So some basic calculation you can also perform here irrespective of doing any code. This is very important, very good feature of the ThingSpeak. Even you want rounding, data minimum, data maximum, you can set threshold. Okay, y-axis minimum, y-axis maximum, like this. Many things you can do. You can do title, x-axis, y-axis. So these are the very good, and the most important thing, this is the free. These are the free. Okay. So I hope you like the video. If you like, please don't forget to like and subscribe this channel. Till next video, take very good care of yourself. Take care and Allah Hafiz.